Let's talk about some of the applications of data science in our life. So again, this is the definition of data science: extracting knowledge from large-scale data and use it for future applications like prediction, decision making, and recommendations, and so on. Many other applications and purposes. The first example is recommender systems. Okay, the systems that learn from your historical data and then recommend something for you. So this example, let's start with this very well-known example. Netflix. Well, they changed the format right now. Right now the recommendation is in the form of thumbs up, thumbs down, but before it was in this format. So Netflix Prize is a very famous example of recommender systems. So a couple of years ago, Netflix started a competition, $1 million competition, for the best algorithm to predict user ratings for films based on previous ratings without any information about the users or films. So the people who designed this algorithm, they didn't have any information about users, okay? No information about the user and no information about the movies, about the films. They just knew what was the previous ratings, what was the previous feedbacks and ratings of each user. So for example, if the user's feedback for this movie Breaking Bad series was 4, for House of Cards was 5, for I don't know, The Big Bang Theory, for example, these are just examples, was 3, then the algorithm can predict what is your rating for another movie or series, for example, Game of Thrones. So the competition was for designing the best algorithm that can predict something like that. Okay, the best recommender system that can do this. And again, the decision making only was based on these previous ratings. Okay, so the algorithm only knew that, for example, user A ratings was for these 3 movies was what, and then try to predict the future. That's it. So many different scientists all around the world entered into this competition, and it was a difficult competition because there was massive data, 100 million ratings from 480,000 users from 880,000 users for 18,000 movies. It was the size of the data, and the data was it was very large in size, but at the same time it was very sparse because many of these users didn't watch many of these movies. So the table of ratings included a lot of missing values. Okay, only maybe 1% of movies were watched by these users. So almost 99% of the table of ratings was just blank. So the grand prize of 1 million was given to this team, Belcour's Pragmatic Chaos team. And the name looks a little weird because it was actually the combination of 3 different teams together that could get the best results. They could improve the accuracy of Netflix prediction model by almost 10%. Okay, so this was an example for recommender systems. We have another type of recommender system. Of course, you use it every time you buy something from an online website like Amazon. So again, you purchased, for example, something like a camera from Amazon website, and right after that you see that it recommends you to buy some other things, okay, which are similar to, which are related, not necessarily similar, which are related to your original purchase. And this is actually a very helpful service, so many times we use it. But how does it work? So the thing is that nobody tells the algorithm, nobody tells the Amazon website that, for example, a camera bag is related to camera. Okay, nobody did that. Nobody told, nobody defined or hard-coded somewhere in the Amazon website that there is a connection between camera bag and camera. It's impossible. There are millions of items and it's impossible to define these connections and correlations. The very interesting part is that the algorithm, the Amazon website, understands this and learns this from data, from historical data of other users. So the website, the algorithm, the data science and machine learning algorithms in Amazon website, they learn from previous users that anybody who was interested or purchased this item maybe later on searched for this item. Okay, so the website, by time, by learning from historical data, from previous users' experience, it learns that there is a connection that between these two, that users that purchase this item, they might be interested in this item too. And from now on, it recommends new users to purchase this one, the second one. Actually, Netflix does the same thing. So it learns this prediction, this future predictions from it learns these future predictions from the historical data, from the ratings that other users put on the websites from before. So it uses some kind of well-known machine learning algorithms that we are going to talk a lot about it. But generally speaking, it is data science because it's learned from data. It's data-driven algorithms. Another application, another example is like speech recognition and natural language processing systems and tools. Many of us use these technologies these days, like Apple Siri or Amazon Alexa or Google Home and so on. Again, they are all based on data science techniques and algorithms. They learn from data, they extract knowledge from data. Predicting in marketing or a stock market is another important applications of data science. Okay, so there are a lot of data. We process that data using different algorithm and techniques that you will learn in that class, like machine learning algorithm, and try to predict future. Okay, predict future. So from what happened in the past, from what happened to that specific stock in the past, you can predict what will happen to this in the future. And this is what many of those financial companies are using, these technologies. So this is again another application of data science, and same thing for real estate prediction. So websites like Redfin and Zillow, maybe you know them, they use this technology to predict the value of a house in future, or estimate the value of a house right now. Robotics is a very important applications of data science and AI, which are very connected topics. I'm gonna talk about like data science, artificial intelligence, and machine learning later on. But generally speaking, each robot has a brain, of course, and this brain is a computer with data science capabilities or AI capabilities, because it learns from data. It collects data, process it, and all of them are, again, includes AI algorithms based on machine learning techniques that learns from data. The algorithms, the main algorithms, are data driven. Almost all of the email frameworks, like for example your Gmail and so on, Hotmail, Gmail, whatever email you use, they include some kind of spam detection, and they are again data driven algorithms. They are data science, so they use the historical data to discover the pattern of spam, and then use that pattern to predict and detect if a new email is a spam or not. Social media, of course, one of the most important applications of data science is in social media. They have social media like Facebook, they have many different data science algorithms and techniques to do many different things, to, for example, better find the content for you that might be of your interest, based on your behavior in the past, connect people together, or find the best advertisement for you, and it's an important application of that, based on your posts, your likes, your comments, and so on. It can figure out what items you might be interested in, and then show you some advertisement for those items. Okay, so these are again different applications of data science. Everything is data driven. Object recognition, we're going to talk about it in computer vision. This is a very simple example. It looks simple because all of us have it. Okay, if you have a smartphone, your smartphone includes a face recognition algorithm. When you take a photo, it detects all of the faces. So again, these are machine learning algorithms, an important topic in data science that we're going to talk about it later. Self-driving cars, of course, it learns from data. So again, you don't program this system how to drive. Okay, it learns. There are different levels of machine learning for detecting object, for example, in computer vision part, all the way to driving. It learns how to drive from experience. So if, for example, a human driver behind the car and drives, the machine learning algorithm and the data science algorithm in the car, in a self-driving car, will learn how to drive from that person. This is how they train their models. And also there are a lot of computer vision algorithm that learns to detect different objects. For example, a car, a pedestrian, a bicyclist, a truck, a tree, all of those items. It detects all of those objects, again, using data-driven techniques and machine learning algorithms. We'll talk about it in this class. Healthcare, my favorite application. You can use data science to save people's life, right? Actually, this is exactly my favorite field of research, using data to build, for example, data science models, machine learning models that can, for example, predict medical conditions before happening, okay? Or detect, for example, a cancerous tumor in a medical image, and so on. Many different applications. So in your homeworks in this class, you will see some of the applications, how we can use data science and machine learning in healthcare. For more information about some of our projects that we do here at Cal State LA, please go see my website, my research website, calstatela.edu/research/data science. So this is my research lab, artificial intelligence and data science research lab. You can go ahead and see some of our projects. I have a lot of students, undergrad and graduate students, and that taking thesis with me and working on real life projects in the field of data science and machine learning. Let me briefly talk about ingredients of data science. So there are three main parts, components of data science that are required to do a real data science project. So of course the first one is data, okay? So you cannot do data science without data. So you will select a project for this class, and you are free to select your topic. I'm gonna talk about this later, but remember, you cannot select because it happens a lot every year. Students have a very interesting idea to do something, very novel idea to do something, but because the data is not available for that specific application, we are not able to do data science, okay? So remember that we need data. This is the first component. Machine learning algorithms, that is gonna be our next topic. We use it every day. All of these applications that I talked about, like recommendation systems, market prediction, speech recognition, face detection, fraud detection, spam filtering, vehicle, medical diagnosis, they are all use machine learning algorithms. And big data manipulation and processing. So in many cases these days our data is large, and we should be able to manipulate that and process that large data to be able to extract knowledge from it. So these are the three ingredients, and these are the three components that I'm gonna talk about it in this class. So most of our class will focus on data processing, machine learning, and big data manipulation techniques.